Hi, I'm Glen from Queen's University Belfast, and I'm here to present our paper Utilizing Domain Transformations in Multi-Camera Reidentification Scenarios Beyond Data Augmentation. So, just as in a standard Re-ID scenario, we have a gallery set of images and a query set of images, and we want to match the images in our query set to known identities in our gallery set. In addition, our datasets consist of multiple cameras, and each camera tends to have its own intrinsic properties. These are things like the quality of the camera, the lighting scenario the camera is set up in, as well as the relative position between the camera and its subjects. And it is these differences between the cameras that we're going to leverage to improve reidentification performance. An existing system that does this is called CamStyle, and it consists of three main stages. The first of which is to train a CycleGAN for every pair of cameras in the dataset. A CycleGAN allows you to perform a domain transformation from one domain to another, as well as the inverse transformation, hence the cycle in CycleGAN. Therefore, by simply treating each camera as its own separate domain and training a CycleGAN for each pair of cameras, we gain the ability to transform any image from any camera in the dataset into any other camera's domain. This is what the second step consists of, augmenting the dataset. Every single image in the training set from every camera is transformed into every other camera. This effectively multiplies the number of images in our training set by the number of cameras in the dataset. The final step of the CamStyle system is to train a standard Re-ID model on the augmented dataset. The key thing to note here is that no domain transformations occur during the testing phase. This feels like a missed opportunity because we have already gone to the trouble of learning these domain transformations, and it should hypothetically be easier to Re-ID images in the same domain than in different domains due to less variance. We therefore decided to extend the CamStyle system to include domain transformations in the testing phase as well. In this example, you can see that prior to extracting feature vectors using our Re-ID model, we transformed the gallery image into the query image's domain using the appropriate CycleGAN. The final distance, as in a normal Re-ID model, is simply the Euclidean distance between the feature vectors. In addition to transforming the gallery image into the query domain, we can also do the opposite, transforming the query image into the gallery's domain, as seen here. And also we decided to evaluate what happens if we take the sum total of these two distances, called disboth. And the results do show that utilizing domain transformations during the testing phase does improve Re-ID performance, with mean average precision increasing over original CamStyle in 3 out of the 4 datasets tested. After further investigating why performance actually dropped for Cox Face DB, it was found that this was due to a substantial data imbalance between the number of images per camera. This led to the CycleGANs overfitting and therefore lost the ability to maintain identity during the domain transformation. In conclusion, utilizing domain transformations during the testing phase does help improve Re-ID performance. In particular, we recommend using the sum of both the query to gallery and gallery to query transformations, as it attained the best or relatively close second best result across all 4 datasets. While the maximum performance benefit might be gained from choosing a particular transform for a particular dataset, the general benefit and seeming robustness of using both makes it a reasonable default. Thank you for listening.